Let's talk about our first recursively defined structure, and that's rooted trees. If you haven't taken data structures yet, you're going to know real well that trees are a recursive data structure. Doesn't it look about the same for each one of these items that are within a tree? The answer is yes, and that's not by a fluke. Frankly, it's nicer to use recursion because, hey, we don't have to reinvent the code each time. That's good news. So trees are naturally recursive. Where a rooted tree comes into play here is that there's a distinguished vertex called the root, and we usually draw it at the very top. The edges are the ones that are connecting everything that we've got here, and we have a couple of key terms of disjointed, which means they're not connected. Like these two trees right here are really not connected. They are disjointed. And then edges is obviously the little lines that are in between that connect everything together. The definition of all of this can sound a little bit more interesting, but what's going to happen is that suppose we have a bunch of trees that are disjointed, rooted trees, so again, each of them have a root. Then we graph by starting with root R, and with a brand new node, and then we connect to the other trees to make it a whole new rooted tree. Now, what does that look like? That's on the next page here. So if I just start off with my base case, just one, what I can then do is I could go ahead and start adding another root, that's the R portion, and then connecting that new node with a node that was already established. Now, these are the individual scenarios that I could have. So I could have, hey, there wasn't anything there, great, that's the first time. Oh, there was already two nodes there, now I connect them to my newest R node, and then keep going. So each one of these is going to be a new scenario. I want to make sure you understand that. This is not all happening at once. This is just different scenarios that could happen just from our start. And then step two is going to be doing the exact same thing over again. So now I created a new node, I connected it with what's already established, and then go from there for each and every one. So the number of possibilities for all of this is kind of crazy. But notice this is creating a tree, and really a set of trees that we can use later on for some other applications down the road. So please note the two notes I have here is that each picture is a possible scenario, anything that's got the purple line between, and each step, no matter the scenario, I apply the recursive definition of just creating a new node and then adding it to an established tree already. That's the same thing over and over again. And then all this creates a set of rooted nodes that we sought recursively. So that's one data structure that we can have as rooted trees.